You are welcome to my channel. Today we'll be solving a question on conversion of plane figures, and we have a quadrilateral ABCD to be converted to a square, which is twice the area of the quadrilateral. But the first question is that we should draw the quadrilateral ABCD, and these are the parameters of the quadrilateral. We have our AB to be 70. AB is 70. AB is 70. And our BC is 50. DA is 35. Angle DAB is 60. Angle ABC is 70. So how do you draw? The first part of the question is to draw the quadrilateral. Let us start from this by drawing a horizontal line. So along the horizontal line, you can pick a point. Let's say this point as A. So we can measure our AB to be 70. Our AB to be 70, 10, 20, 30, 40, 50, 60, 70. Yeah, that's our AB. Or better still, let's move it because of space a little bit to the left. If we pick our point A to be here, this is our point A. So from here we measure 70, 10, 20, 30, 40, 50, 60, this is 70. That is point B. Now, our angle A, because A is at the center, A is the owner of this angle, is 60 degrees. We place it here and measure 60 degrees, 10, 20, 30, 40, 50, 60. And our AD, that's DA, is 35. So you measure 35, 10, 20, 30, 35 is up to this point. That is our D. Now, to get our C, we look for angle B. What's angle B? Angle B is 70. B is at the center, so B is 70 degrees. Place it here like this, and you measure 70. 10, 20, 30, 40, 50, 60, 70 is here. So from this point, we roll it downward. And what is our BC? Our BC is 50. We measure 50, 10, 20, 30, 40, 50. So we make it thick line. The reason why we are making the quadrilateral thick line is because the first part of the question is that we should draw the quadrilateral. So that means your quadrilateral must be in thick line. Now we have drawn our quadrilateral. The next thing, like we did in our previous class, is to convert the quadrilateral into a triangle of equal area. So you join the topmost part of the quadrilateral, you draw a diagonal from it like this. Now this diagonal, you now transfer it to the hanging corner. You can see this D is hanging. You shift it to there, so I can draw a parallel line to AC. So let's say this is E. So we now have a parallelogram ACDE. Now inside the parallelogram, you draw a diagonal like this. So with that diagonal, we have a triangle of equal area. That will be CEB. That's triangle of equal area. So the next thing is to convert our triangle of equal area to a rectangle of equal area. So how do you do that? You drop a vertical line from the vertex, the topmost part of the triangle. Let's say this point is F. If this is F, so the next step is to now bisect it so that we can get a rectangle of equal area. So you put your pin on F, you mark arc to the right and to the left. You go to the top, you mark arc to the right and to the left, like that. So we have this point and this point. So our bisector will pass through those 2 points. So you can place it like this, so that I can draw a bisector like this. So the next thing is to now extend the 2 base corners of the triangle. Remember, our triangle of equal area is CEB. So we will now take B vertically upward and E also vertically upward, like that. So we have a rectangle of equal area to be, let's say this is G and this is H, to be EBGH, rectangle of equal area. Our rectangle still remain in thin line because the question did not ask us to construct a rectangle of equal area. Rather, it asks us to construct a square which is twice the area of the triangle. So now the next stage is to now convert the rectangle of equal area to a square of equal area. How do you do that? You get the height of the rectangle, which is BG. You put it on B and extend your pencil to G, and you describe an arc to intersect with the base like this. So let's say this is J. So now you bisect between J and E. Again, you bisect between J and E. You put your pin on J, open your compass at least more than half of distance between E and J, like this. Make sure you place it very well on J. So you mark arc above and below. You go to E, you mark arc above and below. So you have the bisector passing through this point and this point. So we can draw our bisector. You draw the bisector like that. So after drawing the bisector, the next thing, let's say this point is point O, where the bisector is intersecting the base. Now, making O the center of a semicircle that you describe, and radius OE. You extend the radius to the end of the base corner of the triangle of equal area, which is E or J. Which is E, or you can also extend it to J, like this, to describe your semicircle, like this. Good. So when you are done with that, you now extend the rectangle BG to touch the semicircle. Extend it. It's touching the semicircle here we stopped at J. Let's say this is K. So BK is the length of square which is of equal area to the quadrilateral. So now let us draw the square which is of equal area. Put it on K like this. You describe an arc like this. You can also put it on like this. Describe another arc like this. So at that point now, you can now draw a vertical line on this point. A vertical line like this. You see, it is intersecting the other arc here. Then you join the 2 points together like that. So K, let's say this is L and this is M. So BKLM is square of equal area. A square that has the same area as the rectangle, it has the same area as the triangle, and has the same area as the quadrilateral. Now, but the question is that we should draw a square which is twice the area of the quadrilateral. So to do that, you need to draw a diagonal in the square of equal area like this. When you have drawn the diagonal, you can put your set square under this set square you slide it away a little bit away and draw a perpendicular line from M like this and K here like that. So now the next thing, this is the side of the square which is twice equal the area. So this same side, you measure it here. You can measure the side and measure the same measurement here. But to make it easy for yourself, you can just put your pin on M and extend it to K. Just describe an arc like this. You can extend the line a little bit so that I can intersect it like that. So once you have done that, you now draw this parallel line at to this point, because this length is equal to this length. Now, how do you draw the parallel line? You can put it like this. Put it on the parallel line first. Put your set square under it and slide this one to that point. So then let us extend this one to meet it. So we stop at M. So let's say this is N P. So KNPM is the square of equal area of twice the area of the quadrilateral. So you make it thick. You make it, draw it with thick line. Now, so you can now state here that MPNK is the required square twice the area of the quadrilateral. So now that is how to solve the problem. That is how to solve the problem. So, and if you take note, we only have the quadrilateral and the rectangle and the square of twice the area of the quadrilateral to be thick line. All other lines are thin line. They are construction lines, because the question only asks us to construct the quadrilateral and convert it to a square which is twice the area of the quadrilateral. So that is the solution to the question. If you have enjoyed this video, ensure you like, you share and subscribe to the channel. Thank you very much. We'll meet in the next video.